Position in the periodic table. Objective questions. Question 1. The periodic table is a tabular arrangement of elements based on A. Atomic number, B. Atomic mass, C. Number of neutrons, D. Number of electrons. Answer A. Atomic number. Question 2. The horizontal rows in the periodic table are called A. Periods, B. Groups, C. Families, D. Blocks. Answer A. Periods. Question 3. The vertical columns in the periodic table are called A. Periods, B. Groups, C. Families, D. Blocks. Answer B. Groups. Question 4. Elements in the same group have similar A. Atomic number, B. Atomic mass, C. Chemical properties, D. Physical properties. Answer C. Chemical properties. Question 5. Elements in the same period have the same number of A. Electron shells, B. Valence electrons, C. Neutrons, D. Protons. Answer A. Electron shells. Question 6. The S-block elements are located in A. Groups 1 and 2, B. Groups 3 to 12, C. Groups 13 to 18, D. Lanthanides and actinides. Answer A. Groups 1 and 2. Question 7. The P-block elements are located in A. Groups 1 and 2, B. Groups 3 to 12, C. Groups 13 to 18, D. Lanthanides and actinides. Answer C. Groups 13 to 18. Question 8. The D-block elements are located in A. Groups 1 and 2, B. Groups 3 to 12, C. Groups 13 to 18, D. Lanthanides and actinides. Answer B. Groups 3 to 12. Question 9. The F-block elements are located in A. Groups 1 and 2, B. Groups 3 to 12, C. Groups 13 to 18, D. Lanthanides and actinides. Answer D. Lanthanides and actinides. Question 10. The atomic size generally A. Increases across a period, B. Decreases across a period, C. Remains constant across a period, D. Depends on the element. Answer B. Decreases across a period. Electronic configuration of D-block elements. Objective questions. Question 1. The general electronic configuration of D-block elements is A. Ns2, Np1 to 6, B. N1d, 1 to 10 nanoseconds, 1 to 2, C. Ns2, Np6, Nd 1 to 10, D. N2f1 14, N1d 0 to 10 nanoseconds, 2. Answer B. N1 Jeshiel 1 to 10 nanoseconds, 1 to 2. Question 2. The D-block elements are also known as A. Alkali metals, B. Alkaline earth metals, C. Transition metals, D. Halogens. Answer C. Transition metals. Question 3. The maximum number of unpaired electrons in a D-block element is A. 2, B. 5, C. 7, D. 10. Answer B. 5. Question 4. Which of the following elements has the highest number of unpaired electrons in its ground state? A. Cr, B. Mn, C. Fa, D. Co. Answer B. Mn. Question 5. The electronic configuration of Cr, atomic number 24 is A. 3, D. 4, 4s2, B. 3, D. 5, 4s 1, C. A 3d 6, 4s0, D. A 3d 4, 4s1, 4p1. Answer B. 3d 5, 4s 1. Question 6. The electronic configuration of Cu atomic number 29 is A. 3, D9, 4, S2, B. 3d 10, 4s 1, C. 3d8, 4, S2, 4p1, D. A very tall man Jeshiel 4s 2. Answer B. 3d 10, 4s 1. Question 7. The stability of half-filled and fully filled d orbitals is due to A. Hund's rule, B. Of Pauli principle, C. Pauli exclusion principle, Bena, D. Exchange energy. Answer D. Exchange energy. Question 8. Which of the following elements shows the maximum number of oxidation states? A. Sc, B. E, C. Mn, D. Zn. Answer C. Mn. Question 9. The color of transition metal ions is due to A. D-D electronic transitions, B. S-S electronic transitions, C. P-P electronic transitions, D. Charge transfer transitions. Answer A. D-D electronic transitions. Question 10. Which of the following is not a property of transition metals? A. Variable oxidation states. B. Formation of colored compounds. C. Catalytic properties. D. High ionization energies. Answer. D. High ionization energies. Would you like more questions? Or do you have any other? The d block elements are characterized by A. Completely filled d orbitals. B. Partially filled d orbitals. C. Completely filled s orbitals. D. Completely filled p orbitals. Answer. B. Partially filled d orbitals. Question 2. Most d block elements exhibit A. Low melting and boiling points. B. High melting and boiling points. C. Non-metallic character. D. Low density. Answer. B. High melting and boiling points. Question 3. The ability of transition metals to form colored compounds is due to A. D-D electronic transitions. B. S-S electronic transitions. C. P-P electronic transitions. D. Charge transfer transitions. Answer. A. D-D electronic transitions. Question 4. Transition metals generally form A. Ionic compounds only. B. Covalent compounds only. C. Both ionic and covalent compounds. D. No compounds. Answer. C. Both ionic and covalent compounds. Question 5. Many transition metals exhibit A. Variable oxidation states. B. Fixed oxidation states. C. No oxidation states. D. Only positive oxidation states. Answer. A. Variable oxidation states. Question 6. Transition metals and their compounds often act as A. Catalysts. B. Acids. C. Bases. D. Oxidizing agents. Answer. A. Catalysts. Question 7. The magnetic properties of transition metals are due to A. Unpaired electrons. B. Paired electrons. C. Filled orbitals. D. Empty d orbitals. Answer. A. Unpaired electrons. Question 8. The formation of complexes by transition metals is due to A. Large size of metal ions. B. Availability of vacant d orbitals. C. High electronegativity. D. Low ionization energy. Answer. B. Availability of vacant d orbitals. Question 9. Transition metals are generally A. Soft and malleable. B. Hard and brittle. C. Ductile and malleable. D. Non-conductors of electricity. Answer. C. Ductile and malleable. Question 10. Which of the following is not a general property of transition metals? A. Formation of colored compounds. B. Catalytic properties. C. Low melting points. D. Variable oxidation states. Answer. C. Low melting points. Would you like more questions? Or do you have any other? Important compounds of transition elements. Objective questions. Question 1. Potassium permanganate. Potassium permanganate is a strong A. Oxidizing agent. B. Reducing agent. C. Catalyst. D. Complexing agent. Answer. A. Oxidizing agent. Question 2. Potassium dichromate. Potassium dichromate is used as A. Oxidizing agent. B. Reducing agent. C. Catalyst. D. Precipitating agent. Answer. A. Oxidizing agent. Question 3. Ferrous sulfate, iron 2 sulfate, is used in the treatment of A. Anemia. B. Fever. C. Cough. D. Diarrhea. Answer. A. Anemia. Question 4. Copper sulfate. Copper 2 sulfate is used as A. Fungicide. B. Insecticide. C. Fertilizer. D. All of the above. Answer. D. All of the above. Question 5. The compound used as a catalyst in the Haber process is A. Iron. B. Copper. C. Nickel. D. Zinc. Answer. A. Iron. Question 6. The compound used as a pigment in paints is A. Titanium dioxide. B. Zinc oxide. C. Iron oxide. D. All of the above. Answer. D. All of the above. Question 7. The compound used in photography is A. Silver nitrate. B. Sodium chloride. C. Potassium bromide. D. Ammonium chloride. Answer. A. Silver nitrate. Question 8. The compound used as a drying agent is A. Copper sulfate. B. Calcium chloride. C. Zinc sulfate. D. Magnesium sulfate. Answer. B. Calcium chloride. Question 9. The compound used in the treatment of cancer is A. cisplatin, B. Aspirin, C. Paracetamol, D. Ibuprofen. Answer A. Cisplatin. Question 10. The compound used in glass making is A. Sodium carbonate, B. Calcium carbonate, C. Lead oxide, D. All of the above. Answer D. All of the above. Would you like more questions or do you have any other question? Lanthanides. Objective questions. Question 1. The lanthanides are also known as A. Rare earth elements, B. Alkali metals, C. Alkaline earth metals, D. Transition metals. Answer A. Rare earth elements. Question 2. The general electronic configuration of lanthanides is A. 4F11, 45D0, 16S2, B. 5F11, 46D017S2,
C. 4D1105S2,
D3D110 2. Answer A. 4F11, 45D0, 16S2. Question 3. The lanthanide contraction is due to A. Poor shielding of 4F electrons, B. Strong shielding of 4F electrons, C. Increased nuclear charge, D. Decreased nuclear charge. Answer A. Poor shielding of 4F electrons. Question 4. The oxidation state commonly exhibited by lanthanides is A plus 1, B plus 2, C plus 3, D plus 4. Answer C plus 3. Question 5. Lanthanides show A. Variable oxidation states, B. Fixed oxidation states, C. No oxidation states, D. Depends on the element. Answer B. Fixed oxidation states. Question 6. The color of lanthanide ions is due to A. D-D transitions, B. FF transitions, C. Charge transfer, D. None of the above. Answer B. FF transitions. Question 7. Lanthanide compounds are generally A. Colored, B. Colorless, C. Fluorescent, D. Phosphorescent. Answer A. Colored. Question 8. Lanthanides are used in A. Phosphors for television screens, B. Magnets, C. Catalysts, D. All of the above. Answer D. All of the above. Question 9. The lanthanide contraction affects the properties of A. Only lanthanides, B. Actinides, C. D-block elements, D. All of the above. Answer D. All of the above. Question 10. Lanthanides are found in A. Monazite, B. Bastnasite, C. Both A and B, D. None of the above. Answer C. Both A and B. Would you like more questions or do you have any other? Actinides. Objective questions. Question 1. The actinides are also known as A. Rare earth elements, B. Transuranium elements, C. Alkali metals, D. Alkaline earth metals. Answer B. Transuranium elements. Question 2. The general electronic configuration of actinides is A. 4F1, 145D0, 16S2, B. Rn5, F1, 146D0, 17S2,
C. 4D1105S2,
D. A 3D1, 10 force 2. Answer B. Rn5, F1146D0, 17S2. Question 3. Most actinides are A. Naturally occurring, B. Synthetic, C. Non-radioactive, D. Stable. Answer B. Synthetic. Question 4. The most common oxidation state exhibited by actinides is A plus 2, B plus 3, C plus 4, D plus 6. Answer C plus 4. Question 5. Actinides show A. Variable oxidation states, B. Fixed oxidation states, C. No oxidation states, D. Depends on the element. Answer A. Variable oxidation states. Question 6. The color of actinide ions is due to A. D-band-T transitions, B. F transitions, C. Charge transfer, D. None of the above. Answer B. FF transitions. Question 7. Actinides are characterized by A. High density, B. High melting points, C. Radioactivity, D. All of the above. Answer D. All of the above. Question 8. The first transuranium element to be discovered was A. Neptunium, B. Plutonium, C. Uranium, D. Thorium. Answer A. Neptunium. Question 9. actinides are used in A. Nuclear reactors, B. Nuclear weapons, C. Medical applications, D. All of the above. Answer D. All of the above. Question 10. The actinide contraction is A. More pronounced than lanthanide contraction, B. Less pronounced than lanthanide contraction, C. Similar to lanthanide contraction, D. Not observed. Answer A. More pronounced than lanthanide contraction. Would you like more questions, or do you have any applications of D and F block elements? Objective questions. Question 1. Iron is a crucial component in A. Hemoglobin, B. Chlorophyll, C. Was so tall man Jeshil, very tall was in the clouds, D. All of the above. Answer A. Hemoglobin. Question 2. Titanium alloys are widely used in A. Aerospace industry, B. Medical implants, C. Both A and B, D. Neither A nor B. Answer C. Both A and B. Question 3. Copper is used in electrical wiring due to its A. High electrical conductivity, B. High melting point, C. Low density, D. Malleability. Answer A. High electrical conductivity. Question 4. Zinc is used in the prevention of A. Anemia, B. Goiter, C. Rickets, D. Scurvy. Answer A. Anemia. Question 5. Lanthanum oxide is used in A. Ceramic industry, B. Glass industry, C. Both A and B, D. Neither A nor B. Answer C. Both A and B. Question 6. Cerium oxide is used as A. Catalyst, B. Polishing agent, C. Pigment, D. All of the above. Answer D. All of the above. Question 7. Neodymium magnets are known for their A. High magnetic strength, B. Low magnetic strength, C. Non-magnetic properties, D. Diamagnetic properties. Answer A. High magnetic strength. Question 8. Uranium is used as A. Nuclear fuel, B. Pigment, C. Catalyst, D. Fertilizer. Answer A. Nuclear fuel. Question 9. The use of transition metal complexes in chemotherapy is based on their A. Ability to bind to DNA, B. High reactivity, C. Low toxicity, D. Solubility in water. Answer A. Ability to bind to DNA. Question 10. Which of the following is not a correct application of D block or F block elements? A. Titanium dioxide as a white pigment, B. Copper as a catalyst in the Haber process, C. Neodymium magnets in electric motors, D. Lanthanum oxide in ceramic capacitors. Answer B. Copper as a catalyst in the Haber process. Iron is used as a catalyst in the Haber process. Would you like more questions, or do you have any other